Good morning, everyone. In the last session, we completed our discussion related to Linux. So from today, we are going to start with Devops Tools. All right. So we already discussed in our introduction classes, what is the DevOps, why DevOps, right? What is software development lifecycle, where DevOps comes into picture, and what are the tools that we are going to use to make our application delivery process faster, right? So what are the DevOps tools that are available? Let's quickly revise. First, we are going to use build tools like Maven and Gradle. Maven and Gradle are called as build tools. They are used to automate build process of the application. And the second one, GitHub and Bitbucket available, which are used to maintain project source code. GitHub and Bitbucket, they are called as source code repository servers. And the third one, Nexus and JFrog, they are used to maintain project artifacts. Whenever we build our application, project artifact will be generated. To store that project artifact, we are going to use Nexus and JFrog. Then Apache Tomcat, that is used to run our Java web applications, right? Maven and Gradle are called as build tools. They are used to automate build process of the application. GitHub and Bitbucket, they are used to maintain project source code, right? Nexus and JFrog, they are used to store project artifacts. Tomcat is a web server which is used to run our web application. Then next one, Jenkins or SonarQube. SonarQube is used to perform code review. When developers has done the coding, does that code having some quality or not? Are there any issues in the code that can be identified by using SonarQube? Okay. Then Jenkins. Jenkins is used to automate complete project build and deployment process. Jenkins is called as CI/CD software. Whatever the code is available in the GitHub, so taking the code from the GitHub, build that code by using Maven, upload that artifact into Nexus, perform the code review, deploy into Tomcat. All these things can be done by using this Jenkins. Jenkins is called as CI/CD software. And next one, Terraform. Terraform is used to create infrastructure in the cloud platform. So what are the machines, the databases that are required can be created by using Terraform scripts. Terraform is used for infrastructure creation in the cloud platform. And the next one is Ansible. Ansible is used for configuration management. Once we created infrastructure in the cloud by using Terraform, we need to manage the infrastructure. That means we need to take care of some configurations in the infrastructure, installing the required softwares, copying the files from one server to another server. All those things can be done by using Ansible. Then next, the most important part is Docker. Docker is called as containerization software. Docker is called as containerization software, which is used to package and run our application in any platform without bothering about infrastructure. Next, to manage Docker containers, we are using Kubernetes. Kubernetes is called as orchestration platform. It is used to manage Docker containers. That means creating the containers, recreating the containers, scale up, scale down, load balancing, all the activities, management activities on the Docker containers will be done by Kubernetes. And along with this, we need to understand Grafana. Grafana is called as visualization software, which is used to monitor our Kubernetes cluster and applications running in the Kubernetes cluster. And the next one is Prometheus. Prometheus is also called as alerting and monitoring software. To monitor our servers, to monitor our applications, we will go for this Grafana and Prometheus. And the next one is EFK stack, Elasticsearch, FileBeat, and Kibana. These are used to aggregate logs of our application. When we go for Kubernetes cluster, multiple servers, multiple nodes will be available. Our application will be running in the multiple nodes. We need to collect the logs from all the nodes and we need to aggregate the logs at one place to monitor the application issues. That's where EFK comes into picture. That is Elasticsearch, FileBeat, and Kibana. To monitor application logs at one place, we are going to follow this. And the next one, Jira. Jira is called as project management software, right? So work assignment, it is also called as a ticketing tool. So what is the work that we need to do? Our work will be planned in the Jira. Our task will be available in the Jira. Task will be assigned to team members. So we need to take the Jira story. We need to work on that and we need to give the update on the story to our Scrum Masters. So your task assignment, your work assignment will be happening in the Jira software only. Jira is called as project management software. Okay. As a DevOps engineer, you need to work with these tools, guys. So to say that you are a DevOps engineer, you need to have the idea and you need to have practical work experience on these tools. These are called as DevOps tools. By using these DevOps tools, we can automate project build and deployment process, and we can deliver application to the client quickly. That is called as DevOps tool chain. First one is Maven and Gradle. They are called as build tools, right? They are used to automate the build process. Second one is GitHub and Bitbucket. They are called as source code repository servers. Third one, Nexus and JFrog, Artifactory servers. Tomcat is a web server to run our web application. SonarQube is a code quality checking software to find the mistakes of the developers in the code. Jenkins, CI/CD software to automate build and deployment process. Terraform, infrastructure provisioning software in the cloud. Using Terraform, we can provision the infrastructure in the any cloud platform like AWS, GCP, and Azure also. Currently, in our course, we are using AWS. So to create infrastructure in the AWS, we will use Terraform. Ansible. Ansible is called as a configuration management software. Then a Docker. Docker is a containerization software. Kubernetes. Kubernetes is orchestration platform. Grafana, monitoring software. Prometheus, alerting software. EFK, log aggregation tools. Elasticsearch, FileBeat, and Kibana. And Jira. Jira is called as project management software. Jira is called as project management software. Are you guys clear? Are you guys clear with the DevOps tools that we are going to learn? So whatever the tools I have mentioned here, all the tools we are going to learn as part of our course, DevOps tools. All right. So first we are going to start with build tools. Those are Maven, Gradle. First we are going to understand how to work with build tools, right? So before going to understand the build tools, first we need to understand project execution flow. So first we are going to take a Java project and we are going to understand how Java projects are going to execute. So first let's understand what is this Java and why we need to go for Java, how Java projects are going to execute. So the first thing is Java is a programming language. Java is a programming language developed by Sun Micro system. Developed by Sun Micro system in 1991. So this is a programming language. So first of all, let's understand what is a programming language and why we need to go for a programming language, right? Assume that there are two humans available, guys. Assume that there are two humans available. One human wants to communicate with another human. If one human wants to communicate with another human, we need one language as a mediator. So we can use English, we can use Hindi, we can use Telugu, Chinese, Japanese. Like this, there are some languages available. By using these languages, only one person can communicate with another person. All right. So if one person wants to communicate with another person, one language is required. So we are using global language, English. Some people will use their local languages also for communicate. Right. So when I'm speaking in the class, I'm using English because people are available from different countries in our class. So common language for all of us in this class is English. So I'm using English to communicate with you. If you want to communicate with me, you will also speak in English. After class is completed, in my home, we will speak in our mother tongue, Telugu. Right? So one person wants to communicate with another person, then we need one language as a mediator. Similarly, here, one person wants to communicate with a computer. How one person is communicating with another person? Similarly, one person wants to communicate with one computer to perform some operation, to store some data, or to watch a movie, or to do some operations, or to do some calculations. A human wants to communicate with a computer. Computers can understand our language. Computers cannot understand our language. Computers will understand only binary language, that is ones and zeros. Computers will understand only binary language, ones and zeros. Humans will understand normal languages like Telugu, Hindi, English. Computers will understand binary language. So here, if a human wants to communicate with a computer, we need one programming language as a mediator. If one human wants to communicate with another human, we are using one language as a mediator. Similarly, if one human wants to communicate with a computer, then we need programming language as a mediator. So there are so many programming languages are available: C, C++, Java, Python, C#, etc. Okay, guys. So these all are called as programming languages. So why we need a programming language? Programming languages are used to communicate with the computer. Here, computers will understand a binary language. Humans cannot understand the binary language. Humans can understand English, Hindi, Telugu. Computers will understand binary language. So there is a mismatch between the human's language and computer's language. So then how can we communicate with a computer? If a human wants to communicate with a computer, then that human should speak in the computer understandable language. We can't speak that computer understandable language. That's why we are using one mediator. That mediator is called programming language. Humans will write the programs. The programs we are going to execute in the computer. Humans will write a program. That program will be executed in the computer. So here, computers we are going to use to perform our operations easy. How can we communicate with the computer? To communicate with the computer, programming languages are required. C, C++, Java, Python, C#, these are called as programming languages. Okay. So what is Java? Java is a programming language developed by Sun Microsystem in 1991. In 2010, Oracle acquired Sun Microsystem. In 2010, Oracle Corporation acquired Sun Microsystem, acquired Sun. So now Sun Microsystem company not available, guys. Java is under license of Oracle Corporation. So this is Java developed by Sun Microsystem in the 1991, but the official version of Java came into market in the 1995. In 2010, Oracle Corporation acquired this Sun Microsystem. Oracle Corporation acquired Sun Microsystem. So now Sun Microsystem is not available. Java is under license of Oracle Corporation. Java is under license of Oracle Corporation. Now here, how we are going to develop this Java program, how we are going to execute this Java program. So let's understand. developers are going to write source code, guys. Whatever the source code they are writing, that source code they will keep in the .java file. Sir, we are DevOps people. Why are you teaching Java? So you need to, as a DevOps engineer, you no need to learn the Java programming, but you should know how Java programs will work. If you understand how Java programs will work, then only you can understand Maven or Gradle build tools. Without understanding the Java program execution flow, you cannot understand that. You can't understand Maven. You can't understand a Tomcat if you don't know Java execution flow. I'm not teaching you Java coding. I'm giving you overview on the Java so that easily you can understand what is your role as a DevOps engineer when your project is based on Java programming language. Okay, so Java is one programming language. It is used to communicate with the computers. Now, developers will be available. Developers are going to write the source code. Developers are going to write the source code. It is like a plain English only. Developers will be writing the source code. Whatever the source code developers are writing, they will keep that source code in the .java file. Okay, this is Java code will be available. So computers cannot understand Java. Why? Computers will understand only binary language. So here humans are using programming languages to communicate with the computer. Computers cannot understand this Java C directly. Computers will understand only binary language. So that's why here, whenever we write a Java program, that a Java program should be compiled. That Java program should be compiled. So now here, Java software will give you compiler. Whenever we compile that Java program, we are going to get a .class file. Inside the .class file, bytecode will be available. So first, developers are going to write the source code. That source code will be available in the .java file. So once that source code is available in the .java file, so we are going to compile that Java program. We are going to compile that Java program. When we compile that Java program, .class file will be created. Once the .class file is created, then we need to run the Java program. When we run the Java program, it is going to start one software that is called JVM. JVM will be available. So whenever you run the Java program by using the .class file, that is called as execution or run. Execute. Or we can say run the program. Compile the program and run the program. Whenever we run the program, JVM is going to start. So what this JVM will do? JVM will convert our program into computer understandable format. So JVM is responsible to convert our program into OS understandable format. That OS may be Windows OS, or it may be Linux OS, or it may be Mac OS. So who is converting Java programs into computer understandable format? JVM is converting the Java program into computer understandable format. OS means it is our machine. Then that OS will convert that program into required output. So this is called Java programs execution flow, guys. So when you go for any project which is developed by using Java, this process will be available. So Java is a programming language which is used to communicate with the computers. Computers will understand only binary language. So here, humans cannot talk to computers directly. That's why we need one mediator. Who is that mediator? Programming language is a mediator. Now, so here, project means set of team members will be available to develop that code. So here, Java project. So developers will write that source code. Source code means .java files will be available. A project may contain 100 .java files, may contain 1000 .java files, may contain 1 lakh .java files. So .java files, collection of Java files, collection of programs is called as a project. So project means a set of programs. So set of .java programs will be available in the project. Those .java programs we have to compile to convert that into bytecode, because .java file contain a source code. That source code is a plain English. computers cannot understand that plain English also. Computers will understand only machine language, ones and zeros, binary language, that is called as a machine code. So whatever the Java program we are writing, that the Java program also should be converted into machine understandable format. So for that, first Java program should be compiled. When we compile the Java program, bytecode will be generated. That bytecode is available in the .class file. Sir, can we read that bytecode? No, bytecode is not human readable. So once we have the bytecode, we need to run the program. Whenever we run the program, JVM will come. JVM stands for Java Virtual Machine. Java Virtual Machine is responsible to convert our Java bytecode into computer understandable format. That is called machine code. Then once computer understands the instructions given by the JVM, that computer will perform the operation and will provide the output for us. So this is called a Java project execution flow or a Java program execution flow. Are you clear with my point? Are you guys clear with my point? How Java programs are going to execute? Are you guys clear with my point? How Java programs are going to execute? Source code, bytecode, then execution. So developers will write the source code. So tomorrow, once you join in the company as a DevOps engineer, developers will give you which code? Developers will give you source code or developers will give you bytecode? Come on, guys. Tomorrow, when you join in the company, developers will give you source code or developers will give you bytecode? Developers will give only source code. So where they will give that source code? They will develop the source code. They will keep the source code in the GitHub. As a DevOps engineer, you need to take the source code from the GitHub and you need to compile that source code and you need to deploy that source code. You need to compile that source code and you will get the bytecode. That bytecode you need to execute. So as a DevOps engineer, we should know Java execution flow or we no need to know that? We should know Java project execution flow as a DevOps engineer because we are responsible to build and deploy the Java project or any project, right? Developers will write the source code. Developers will give the source code in the GitHub. As a DevOps engineer, we need to compile the source code into bytecode and we are going to execute it. So this is normal Java project execution flow. This is normal Java project execution flow. Okay, so it is, I'm talking about one program. Here one source file is available which contains the .java code. We can compile that Java code into bytecode and we can execute by using JVM. In order to do this compilation and execution, we need to install Java software in our computer. In order to compile and execute Java programs in our computer, first we need to install Java software in our computer. Whenever we install the Java software, we are going to get two things, JDK and JRE. We will talk about them. We'll talk about them. Right. Are you guys clear as of now? What is the programming language? Programming language is used to communicate with the computers. Humans, if humans wants to communicate with a computer, we need programming language as a mediator. There are so many programming languages available. Out of all the languages, Java is the most famous and powerful programming language available in the market. Okay, Java developed by Sun Microsystem. Later it acquired by Oracle Corporation. Now Java is under license of Oracle Corporation. So what is the Java program execution flow? So .java files will be containing the source code. Developers will write that source code. Computer cannot understand that source code. That source code should be converted into bytecode. For that, we are going to compile the Java program. So who will do that compilation? Java compiler software is available to compile that Java code. Once you compile, you will get a bytecode that is a .class file. Once you have the bytecode, we can run that bytecode. Whenever we run that bytecode, JVM will come into picture. JVM stands for Java Virtual Machine. That JVM will take the bytecode and will convert that bytecode into computer understandable format. That is called machine code. Then computer will understand the bytecode, will process the instructions line by line and will generate the output. So like this, a Java program is going to execute. Now here guys, by using Java, we can develop projects. Using Java, we can develop projects. Using Java, we can develop projects. Right, we can develop several types of projects. So what is the meaning of several types of projects? So we can develop a standalone project by using Java. Standalone application can be developed by using Java. And we can develop web application by using Java. And we can develop mobile applications also by using Java. Okay, a standalone application will be developed by using Java. A web application will be developed by using Java. A mobile application also can be developed by using Java. So first we need to understand what is the difference between these applications. As a DevOps engineer, you are responsible to deploy the application, right? So you need to know what is the difference between a standalone application, a web application, and a mobile applications. So here, what is a standalone application? Standalone application means the application which runs in one computer, that is called as a standalone application. For example, if you take a calculator, if you take calculator is a standalone application which runs in one computer. Our operating system, notepad, these all softwares are running in only one computer. So any application which runs in one computer, only one person can access at a time, that softwares are called as standalone applications. Only one person can access at a time. It can be accessed in only one system at a time. Only one user can access at a time. Suppose if I want to use a calculator in my system, only I can access that calculator. When I am accessing the calculator in my computer, nobody can access that calculator in my computer. Only one person can access that software. So any software which can be accessed only one user at a time, that software is called as standalone application. The best example, our notepad. Notepad is a standalone software. Notepad is a standalone software. Okay, only one person can access at a time, and we need to download and install that software. If you want to use that in your computer, we need to download and install that software. That is called standalone projects. Now, next category, the most famous category, web application. Multiple users can access at a time. So what is a web application? Multiple users can access at a time. What is web application? Web application means multiple users can access at a time. And here the example for the web application, is Gmail, Facebook, IRCTC, Naukri, Flipkart, etc. In our daily life, we will be using so many web applications. So what is web application? The application which can be accessed by multiple users at a time, that application is called as a web application. Gmail, Facebook, IRCTC, these all are comes under web applications. Okay, mobile application, mobile apps. Apps we can install in the mobile. Apps we can install in mobile. Okay, example, we are using WhatsApp. And the next one, we are using Messenger, Instagram, Insta app, etc. So like this, we are going to develop mobile applications also by using Java, right? So Java is the most famous and powerful programming language. It is having a lot of features. And by using this Java, we can develop several types of projects: standalone applications, web applications, and mobile applications. Now, why I am explaining this process is, when the project is developed by Java, if it is a standalone application, Standalone projects will be packaged as a jar file. Standalone, we are responsible to package the project, guys. Remember, standalone projects will be packaged as jar file for deployment. Okay, we are responsible for deploying the Java projects, right? Standalone projects will be packaged as a jar file. Web projects will be packaged as WAR file. Web projects will be packaged as WAR file. Mobile applications will be packaged as APK files. Mobile apps, mobile projects, mobile applications will be packaged as APK file. Okay, but nowadays people are not using Java directly to develop the mobile application because of Android and iOS are having more features. People are going for Android and iOS to develop the mobile applications. Java is not getting used. That Android and iOS developed based on Java, they are having more features. So people are using those things to develop the mobile applications. So nowadays, Java is mainly used to develop the standalone applications and web applications. Out of these two, more 99% of the times, Java is using to develop web application. So how to package our web application? Java web applications will be packaged as a WAR file to run in the server. Java standalone projects will be packaged as a jar file. Java web applications will be packaged as WAR file. Mobile applications will be packaged as APK file. But we are not going to see that mobile application. So Android, iOS, different approach will be available to develop. So we are going to see how to create the jar file and how to create the WAR file. Now, see here, developers are going to write the source code as we discussed. So multiple .java files will be available. Multiple .java files will be available. That the Java files we need to convert into bytecode. And if it, as it is a project, right? That project we need to package into jar file. Okay. Suppose if it is a web application, multiple .java files will be available. We are going to convert that into bytecode. That bytecode we are going to package as a WAR file. So we are responsible for doing this activity. So here Java code will be available. Source files will be available. Source files will be available in the .java files we can say. We can say .java files will be available. Those .java files we need to convert into .class files by using compilation. Once the .class files are created, we need to create a jar in order to execute it. So developers will give you .java files. You need to convert the .java files into .class files. The .class files should be packaged into jar file. Jar stands for Java archive. Jar stands for Java archive, which is used to package all the .class files available in the project. Now here, if it is a web application, here also same thing, .java files will be available. We need to compile the Java files. Then we will be getting .class files. We will be getting the .class files. Those .class files we need to package as a WAR file. If application is a standalone project, then we are going to package our application as a jar file. If our application is a web application, we need to package that application as a WAR file. It is called WAR, web archive. What is the WAR means? WAR means web archive. Okay. So here, observe. Java is a language to develop the projects, right? So a single Java program, if you consider, we need to compile the Java program. Source code will be available in the .java file. We need to compile. Then we will get the bytecode. That bytecode we are going to run by using JVM. JVM will convert the bytecode into operating system understandable format and will provide the output. So if we talk about project level, so by using Java, we can develop several types of projects. Standalone projects can be developed by using Java. Web application can be developed by using Java. Mobile application also can be developed by using Java. So what is a standalone application? Any project which runs only in one computer, that application is called as a standalone application. We need to download that software. We need to install the software in our computer. then only we can use it. Calculators, our notepad software, operating system, paint software, these all are standalone. If you install operating system in your computer, then only you can use this software. If you have a second laptop, in the second laptop also you need to install the operating system, then only you can use the notepad, calculator and operating system. Standalone means only one person can use at a time in one computer, right? So I have two laptops. Guys, I have to install the operating system in the two laptops, then only I can use it. So that is a standalone software which runs only in one computer. Suppose if you go for web application, Gmail, I'm using Gmail, you are using Gmail, everybody using Gmail at a time. We no need to install the Gmail in our computer. Directly we can go to browser and we can access that Gmail. Gmail is a web application. Multiple users can access this web application at a time. Gmail, Facebook, IRCTC, these all are called as web applications. Multiple users can access web application at a time. Mobile applications, mobile apps. In our smartphone, we are installing the apps from Play Store, application App Store. We are installing the mobile apps. So to develop those mobile apps also, we can use Java. Got it? Right. So when we develop a standalone project by using Java, that standalone project we need to package as a jar file. Jar stands for Java archive. So developers will give you the source code in the GitHub. We need to take that source code and we need to compile that source code so that .class files will be created. Once the .class files are created, we need to package a jar file with the .class file. Right, that is called build process. Compiling the source code and packaging the project as a jar file is called as build process. Similarly, if you are working on web application, in the web application also .java files will be available. We need to compile the .java files, then we are going to get the .class files. Once we get the .class files, we need to package the .class files into a WAR file. WAR stands for Web Archive. Java standalone project will be packaged as a jar file. Java web application will be packaged as a WAR file. So jar file we can directly run. WAR file we will deploy in the server. To run a web application, we need a server. In that server, we are going to deploy our WAR file. That is DevOps duty. Compiling the project, packaging the project, deploying the project, those are our tasks. Developer's task is writing the source code, giving the source code in the repository, GitHub. We need to take the code from the GitHub. We need to compile that code. We need to execute the test cases of that code. We need to package that code. That is called build process. So as a DevOps engineer, we are responsible for build process. So when we are doing the build process for our application, we need to understand whether that application is a standalone application or whether that application is a web application. If it is a standalone application, we need to package it as a jar file. If it is a web application, we need to package it as a WAR file. Jar stands for Java archive. WAR stands for Web Archive. Are you guys clear? Are you guys clear with my point? Before starting the Maven, I'm giving you the introduction related to Java because Maven is a tool which is used for Java projects build process. So whatever I'm saying you here, compiling the project, packaging the project, that can be done by Maven. To understand the Maven, you need to understand the Java first. Java process, how Java programs will work. Are you able to follow me? Non-IT people, are you getting my points? Non-IT people, are you getting my points?
Yes, sir.
Very good.
Yeah, we are definitely understanding. You can go ahead.
Yep, good. Right, guys. So can you tell me what is a compilation? Can you guys tell me, guys? Can you tell me what is a compile?
Convert the source code into the bytecode.
Converting the source code into bytecode. Why we need to convert the source code into bytecode?
So that the computer can understand.
computers can understand. Basically, JVM will be there between the computer and the bytecode. JVM will take that bytecode, will convert into computer understandable format. Computers will understand which language? Binary language. Computers will understand only binary language, that is ones and zeros. Developers are writing the Java. Computer can understand the Java. Computer cannot understand the Java.
Cannot understand Java directly.
Java is a programming language. Computers cannot understand the Java directly. So that's why Java programs we are converting into bytecode, then we are executing. When we execute the Java program, JVM will come. JVM will take the bytecode. JVM will convert the bytecode into computer understandable format. Between the computer and Java, there is a JVM. JVM stands for, what is the JVM, guys?
Java Virtual Machine.
Java Virtual Machine. Yeah. What is the role of the JVM? Converting the bytecode into computer understandable format. What is the computer understandable format? Computers will understand
0101.
Binary.
only binary language. All good? All of you clear with my point?
Yes, sir.
Yeah. What is a standalone application?
Only one user can access at one time.
The application which can be accessed only in one computer, that is called as a standalone application. What is the packaging format for the standalone application?
Jar file.
Jar.
Jar file.
Jar file. What is the What is a web application?
Multiple users can access it.
Multiple users can access at a time. It is called as a web application. What is the packaging format for the web application?
War.
File.
Will be available. Okay. So tomorrow in the interview, they may ask you a question. What is the difference between jar file and war file? Jar stands for Java archive. War stands for web archive. Java standalone application will be packaged as a jar file. Java standalone application will be packaged as a jar file. Java web applications will be packaged as a war file. Now the question is how to compile the Java programs, how to package the Java programs as a jar file or war file. That's where Maven Gradle comes into picture. Are you guys getting my point? So here we are having several tools in the DevOps. The first category is build tool, Maven and Gradle. Sir, what is the purpose of this Maven and Gradle? Maven and Gradle are used to take care of build process for the Java projects. Compiling the Java projects and packaging the Java projects can be done by using Maven. Same thing can be done by using Gradle also. Maven is supported for only Java, whereas Gradle will support for other programming languages also like Kotlin, Groovy, etc. Maven means only for Java. Gradle means it can be used with Java, Kotlin, Groovy programming languages also. All right. So Maven and Gradle are called as build tools. They are used to automate build process of our application. They are used for build process of our application. So if you are clear with this process, then we will move on to the next concept. Java is a programming language developed by Sun Microsystem. So here Java is under license of Oracle Corporation now. So developers will write the source code. Source code will be available in the .java file. Source code cannot be executed directly. Source code we need to compile into bytecode. For that Java compiler we are going to use. When we compile the Java code, we will get the bytecode in the .class file. We are going to run that .class file. Then JVM will come. JVM stands for Java Virtual Machine. That JVM will convert that bytecode into ones and zeros, which is a computer understandable format to provide the output. Using Java, we can develop several projects, several types of projects, standalone projects, web projects, mobile applications. Standalone projects means they will run only in one computer. Web applications means we can execute them in multiple computers. Okay, guys. Now, mobile apps we can install in the mobile. Now, whenever we develop a standalone project, that standalone project will be packaged as a jar file. Web projects will be packaged as WAR file. Mobile apps will be packaged as APK file. So what is our build process here? .java files will be available. .class files will be available. So we will compile the Java programs. .class files will come. When we convert the .class files, right, we need to package them as a jar file by using Java archive, jar commands. Java archive we need to create. When you have a web application, we need to compile them. We will get the .class files. We need to package the .class files. Then we will get a WAR file. WAR stands for web archive. Standalone projects will be executed as a jar file. Web projects will be executed as WAR file. Perfect. Now, here guys, here Java projects we are going to use to automate the build and deployment process. For that, we are going for Maven. So what is Maven? Let's try to understand what is Maven. The first thing is Maven is a build tool. What is Maven? Maven is a build tool. Maven is a build tool developed by Apache. Maven is a build tool developed by Apache. Free and open source. Free and open source. Developed using Java. It is developed using Java. Maven is used for build automation of Java projects. So what is Maven? Maven is a build tool. Maven software developed by Apache organization. Maven is free and open source software. We can use it for free of cost. We no need to purchase any licenses here to work with Maven. Maven is free and open source software. Maven developed using Java, guys. Maven is using Java only. Maven is a Java software. Maven developed using Java. Maven used to automate Java projects build process. Java projects build process. So what is build process? We will understand this. Maven is a build tool. Maven build tool developed by Apache organization, and Maven is free and open source software. Maven software developed using Java language. Maven is used to automate Java projects build process. So tomorrow my project is Python based. Can I use Maven for Python project? No. Maven is used for only Java projects. Sir, my project is .NET. Can I use Maven? No. Maven is purely Java based software and it is used for only Java projects. Maven is a build tool. It is developed by Apache organization. Maven is free and open source software. Maven software developed by using Java. Maven used to automate projects build process. Sir, here, what is a build process? So what are the steps that are involved in the build process? So build process. Let's understand what is build process. Developers will give the source code. After that, we need to perform the build process. So what is the build process? The build process means we need to compile source code. Or I can say build process means download required dependencies. Download required dependencies. Java people will use some other dependencies in the project. We'll come to what are the dependencies. Download required dependencies. Okay. Add dependencies to build path. Add the dependencies to build path. And the third one, compile source code. Compile source code. Then execute unit tests. Execute unit tests. And the fifth one, package application as jar or var based on the type. So if the project is a standalone, then it will be packaged as a jar file. If it is a web application, then it will be packaged as a var file. So here, download required dependencies, add the dependencies to build path, compile the source code, execute the unit test cases, package application as a jar file or var file. So here we understood what is compiling the source code and what is packaging the jar. But what about the remaining steps in the build process? So first one is downloading the required dependencies. What is the meaning of downloading the required dependencies? Downloading the required dependencies means here our Java project we are developing. So developers are going to create the Java project. Whatever the Java project the developers are creating, in that Java project, they will use some third-party frameworks. In the market, there is Apache Kafka, and there is a Redis cache, okay? And there is a Spring, there is a Hibernate, there is a Jackson, etc. These all are third party, not given by Java, but we are going to use them in the Java project for our functionality. Okay, Apache Kafka is a third party library, Redis is a third party library, Spring is a third party library, Hibernate is a third party library, Jackson is a third party library. These are called as libraries, or I can say dependencies. So developers will take care of these dependencies, guys. So Java project means only by using Java we are not going to develop. In the Java project, we are going to use some third-party libraries, third-party frameworks we are going to use to develop the Java project. Those are called as dependencies of our Java project. So when I am developing a Java project, in that Java project, we will be using Spring, or we will be using Hibernate, or we will be using Redis cache, or we will be using Apache Kafka. They are called as dependencies. Earlier, people used to download the dependencies and it will keep in the project. But now they don't need to do that process. Maven can do that automation. So if you tell to Maven, hey Maven, in my Java project, I want to use a Spring. Maven will download the Spring, will keep that Spring in the project build path. Okay. Hey Maven, I want to use the Hibernate in my project. Hibernate is a framework developed by other company, Java framework. I want to use the Hibernate in my project. Then Maven will go to Hibernate website and Maven will download the Hibernate software, will keep in the project. So that means as part of the project development, along with Java, developers will use some other frameworks also to simplify the development. Okay. Kafka, Redis, Spring, Hibernate, Jackson, etc. Thousands of dependencies are available like this for the Java. Those are third party. Java language developed by Sun Microsystem. By using that language, we are developing the project. As part of the project, we are going to use some third party. Third party means other company developed softwares we are using in the Java project. So who will download these dependencies? Dependency means our project needs this software to execute. Those softwares are called as dependencies. So those dependencies can be downloaded by Maven. That is a part of build process. Downloading required dependencies comes under build process. After downloading the dependencies, we need to add the dependencies to build path. And we need to compile our source code. That means .java files will be converted to dot class. Once the dot class files are created, unit test cases we need to execute. Developers will write the unit test cases by using JUnit. So you don't need to worry about what is that JUnits. Just you need to execute the JUnits which are given by the developers. Once our JUnits are success, then we are going to package our project as a jar file or war file. So this is called as build process. So earlier, people used it to perform this build process manually. Now we are going to automate that build process by using a tool called Maven. What is Maven? Maven is a build tool. What is a build? Downloading the dependencies, adding the dependencies to the build path, compiling the project source code, executing the project unit test cases, packaging the application as a jar file or war file. That is called as build process. So earlier, people used it to perform these steps manually. Now, we can automate these build process steps by using Maven. As Maven is used to automate these build process steps, Maven is called as a build tool. Maven is called as a build tool. Could you please read these points? Are you guys clear? Are you guys clear with my point? What is Maven? Can you guys unmute your mic and speak out now? What is Maven?
It's a build
It's a
tool.
build tool.
Maven is a build tool.
Maven is a build tool. Can I use Maven with the Python project?
No,
No.
it's only for Java.
For Java.
Yeah, Maven is a build tool that is used only for
Java
Java.
projects.
So by using this Maven, we can automate build process. Can you guys tell me what is build process?
Compiling the
Yeah.
source code using dependencies. build
Download
path.
the required dependency, add dependency to build path, and compile source code and execute unit test and project. Package
Package the applications into the jar or
Jar or
warehouse.
var
Yeah.
files.
What is the meaning of dependency, guys?
library.
Other frameworks.
So Java is a language. By using that language, we are going to develop a project. As part of the project, we are going to use other frameworks. Those frameworks are called as dependencies. So to develop the project, we will use some dependencies. So those dependencies we need to download and we need to give to the project. Instead of we are doing that work, Maven is going to do that work. Are you clear?
Yes.
Good. So Maven is a build tool. Maven is used to automate the build process. Maven software developed by Apache company, and Maven is free and open source. You no need to purchase the Maven. You can directly download it. Maven developed using Java. Maven is used for only Java projects. By using this Maven, we can automate build process. So build process means downloading required dependencies, adding the dependencies to the build path, compiling the source code, executing the unit test cases, packaging our application as a jar file or war file. That is called build process. Dependencies mean the frameworks developed by other companies. Dependencies means the frameworks developed by other companies. Java projects will use those frameworks. Those are called as third-party libraries or third-party frameworks. Dependencies means the frameworks developed by other companies. So Java projects will use these dependencies for the development, right? So downloading the dependencies, all that stuff we are going to do. To work with Maven software, we need to install Java first. Maven is based on Java. So to run Maven in our machine, first we need to install Maven, or I can say, to install Maven in our computer, first we need to install Java software. To install Maven in our computer, first we need to install Java, because Maven is developed by using Java. So Maven is a Java project. So to run this Maven, Java installation is mandatory in our machine. To run the Maven, Java installation is mandatory in our machine. Guys, I'm going to show you how to install this Java and Maven in the Windows computers first. Then I will tell how to install Java and Maven in the Linux computers. Are you clear? Are you guys clear? Perfect. So in order to work with the Maven, first we need to install Java. Because Maven is developed by using Java, first you need to install the Java in our computer, then only we can install Maven in our computer. So Maven is a build tool. Maven is developed by Apache, free and open source, developed using Java. It is used to automate Java projects build process. So it is going to download the dependencies. It will add the dependencies to the build path. It will compile the source code. It will execute the unit tests. It will package the application as a jar or war. What is a dependency? Dependency means the frameworks which are developed by other frameworks. We will tell to Maven to download the dependencies. How to tell to Maven to download the dependencies? We will understand that. We'll come to that point. Okay. First, let's complete the environment setup to work with Maven. So to work with Maven, first we need to install Java. So now let us see how to install Java in our machine. So first we need to download Java. Go to Google, Go to Google, then download Java 8 we are going to download. So as I told you, Java is under license of the Oracle. We need to go to this Oracle website in order to download the Java. Click on Java SE archive downloads. So when you click on that Java SE archive downloads, you will go to this link, guys. So it will ask you to sign up into this Oracle website. You need to create the account in the Oracle in order to download the Java. Now, first I am trying to download the Java on my Windows. If anybody using Mac OS, so you have a Java software here to download. Mac OS. Okay. Now I am using Windows 64-bit. The last option, Windows 64-bit, Java, JDK, exe file is available. I need to click on this file, guys. This is the link for the people who are using Windows operating system. Okay. Now, when I click on this link, which you can see here, when I click on this link, which you can see here, this link, it is asking me to confirm. Click on download. When I click on the download, it is going to ask me to log in into this Oracle account. Okay. If you create account in this Oracle website, then that Java software will be downloaded as a exe file. Okay, I have already downloaded that exe file I have in my system. I want you people to create the account. It is free of cost. You no need to pay the money there. So you can directly download that Java software. Can you guys quickly do that? Can you guys quickly do that? Log in into that Oracle and download it. Make it fast. Make it fast. Are you guys downloading? Yeah, Java SE development kit. Just go to Google. You can type that. Now, here I will log in with my credentials. Click on sign in. When I sign in into my account, that file will be downloaded in the form of .exe. You see, the moment when I sign in, the .exe file is getting downloaded into my system. The .exe file is downloaded into my system. Java software is downloaded. So we need to install this Java software, and we need to set some environment variables to work with this Java. So Java software is downloaded in the form of .exe files. In the notes, I have given clearly, guys, how to do that environment setup. Okay, Java setup, Maven installation. So first we need to download and install Java software. Okay, now Java software is downloaded here. Java JDK software is downloaded. When I double click on this JDK software, it is going to install the Java software. Click on yes. My Java software is getting installed. You can see that my Java software is getting installed in my machine. Now, this is already been installed on your computer. Would you like to reinstall? Yes. Preparing to remove the old one, and it is installing the new Java version. Java 8 I'm installing in my computer. First we'll do the practice in the Windows, then we will see in the Linux also. I'm installing Java in my machine. Yeah, now you can see it is asking next. In the C program files, it is going to install that this is the location of Java where it is going to install by default. Next. Yeah. After that, click on close. So the Java software got installed successfully in my machine. Okay. You go to C program files. You can see that in the program files, Java got installed. You see JDK is available and JRE is available. JDK and JRE will be installed in your machine when you install the Java. JDK stands for Java Development Kit. Java compiler will be available in the JDK. JRE means Java Runtime Environment, which will provide the platform to run our Java application. Once Java installation got completed, then we need to set up Java home and Java path. So these things are very, very important, guys. So these two things are very, very important. We need to set the Java home in the environment variables, and we need to set per path also for Java. How to do that? Go to JDK bin directory, take up to bin directory. This is called path. Now go to system variables in our machine, edit the system environment variables. There you can see environment variables option. There you can see system variables. Path will be available. Click on edit. Here I already have the path for Java. Suppose if it is not available, now my Java path is not available. My Java path and Maven path is not available. I'm removing everything from here. Now observe carefully. Path, edit. Already my Java path is there. I'm deleting that. My Maven path is available. I'm deleting that. Click on OK. Click on OK. So click on OK. So nothing is there in my system. I removed that Java. I have reinstalled it. So once you have reinstalled the Java software, go to program files, go to Java and find out JDK. Take that JDK bin directory. You take up to bin directory. You need to copy this address. Take it. Go to system environment variables. When you type here, you will get edit the system environment variables option. Open that environment variables. Now click on environment variables, and here system variables available. Path is there. Edit that path. If you edit that path, you will get the options like this. That means already these paths are added in my system. I want to add the Java to this path. Okay. Click on new, enter JDK up to bin directory. So this is called my path setup. I am setting the path for Java. Click on OK. Path setup means we are telling to our computer where Java is available, in which location Java is available. We are informing to our computer through environment variables. Environment variables will be used by our computer. We are telling to our computer, my Java software is installed and it is available in this location. Okay. 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 Then after, take the path up to JDK. So path we are setting up to bin directory, guys, remember. But if you see here, I'm taking the path now up to only JDK folder. I'm not going inside the bin. Up to JDK I'm taking. Then again go to system environment variables. System environment variables. Edit the system environment variables. Go to environment variables. Here we need to set it as a Java home. The variable name should be Java underscore home. The value should be the path up to JDK directory. Remember, Java home we are setting up to JDK directory. Path we are setting up to bin directory. Click on OK. Now you see my Java home is available. See program files Java JDK 1.8. Java home is available up to JDK. Path is available up to bin directory. Path is available up to bin directory. Java home is available up to JDK directory. Click on OK. Click on OK. With this, Java setup is completed. I have prepared the notes, guys. I will give you this. Maven installation. Download and install Java. When we install Java, we will be getting two things. One is called JDK. Another one is called as JRE. JDK contains a set of tools to develop the programs. JRE contains a platform to run the program. So this is the link to download the Java. So once download and install the Java, download and install the Java software. Once we download it, set a Java home in the environment variables. So here Java home, C program files Java JDK. This is the path of Java home up to JDK directory. Path up to JDK directory. You need to copy that path up to JDK directory. So then once it is done, set the path for Java. See, path up to JD up to bin directory. Path is equal to up to bin directory. You need to set the path up to bin directory. So once we have done this, open command prompt in your machine. CMD you can open and you can verify Java is installed properly or not. How to verify? Java space hyphen version. If you use Java space hyphen version, it is telling which version of Java is installed in our machine. Java hyphen version is used to check Java is installed in our machine or not. With this, I'm able to see Java space hyphen version. Java is installed in our computer. Java is working. Which version of Java? Java 1.8 version is installed in our machine. So like this, you can go to your machine, type CMD, command prompt will open. In that command prompt, you can execute a command, Java space hyphen version. Which version of Java is installed? We are able to see that. So whenever you get the output like this, that means your Java installation is successful. Java installation is successful. Once the Java installation is successful, then next we need to go for Maven installation. Then next we need to go for Maven installation. Are you guys clear with Java setup first? Downloading Java as a exe, double click on that install. Then we need to set the Java home and we need to set the Java path. After Java home setup is completed, Java path setup is completed, we can verify Java version. So it should display Java version which we have installed. Are you guys clear with my point? It is very simple. Just we need to download the software, install the software, set the Java home, set the Java path. Good. Once the Java home, Java path setup is completed, the next thing is Maven. Download Maven software from Apache website. So this is the link which I have given to download the Maven. Now go to another tab, open this URL. Here you can see Maven downloads. Downloading Apache Maven. So as I told, Apache company developed this Maven. Maven is a free software. Maven is a free software. So downloading Apache Maven. So here Apache Maven softwares are available. You can download this Apache Maven 3.9.0 bin zip. Okay. So you can download this Apache Maven binary zip file. This is the link to download Apache Maven. Copy the link address. I'm giving the link in the chat box. If you click on that link, Apache Maven will be downloaded. All of you. Just I have given in the notes a link to download the Maven. If you select this link and go here, directly it will open Apache Maven 3.9.0 bin.zip. Okay. If you click on this bin, Apache Maven will be downloaded as a zip file. In our Windows, it is downloading as a zip file. So Apache Maven downloaded as a zip file. This is the zip file. You can simply extract that zip file, extract to Apache Maven. Extract to Apache Maven. So this zip file we need to extract. Right. So whenever you extract that zip file, we are going to get a folder. That folder will be looking like this, guys, Apache Maven. So I have downloaded Apache Maven 3.8.6 earlier. Once you extract that Apache Maven, you can see a folder like this. Here also bin will be available. Now, how we have done Java home setup, Maven Java path setup, same thing we need to repeat for the Maven also. Extract Maven zip file and copy extracted Maven folder, copy extracted folder and paste in the C drive. So now Here you see my Maven software is available. I download. We don't need to install the Maven, guys. Java we need to download and we need to install. For Maven, that is not required. Maven you will directly download as a zip file. Okay, I got the zip file. I have extracted. Once I have extracted that, I got a folder like this. I will keep that folder in the C directory. You can keep any location. I kept in the C directory. Now take up to bin directory. Maven path I need to set up. Again, go to system environment variables. Again, I need to go to my system environment variables. I'm typing system. Edit the system environment variables. Go to environment variables. Path is available. Click on edit. Earlier I have added the Java path, right? Now I will be adding Maven path. Path means up to bin directory, guys. Path means up to bin directory. Click on OK. Click on OK. Click on OK. Path setup is completed. Now Maven home setup. Take up to Maven directory. Go to environment variables again. System environment variables. Edit system environment variables. Now, how we configure Java home? Here up to JDK. Now we need to configure mvn_home. That is a Maven home. MVN home or Maven home. Anything you can configure. Maven home you can configure up to Maven directory. Up to Maven directory. So Java home up to JDK directory. Maven home up to Maven directory. Okay. Path means path we are going to set JDK up to bin directory. Maven path means up to Maven bin directory. And remember, Java will be downloaded as a exe file. We need to install that. Maven we will download as a zip file and we will set the Maven home and Java home. So with this, our environment setup is completed. Once it is completed, then let's go to command prompt again and verify Maven is working or not. How to check the Maven is working or not? MVN -v. That is used to verify Maven software is working in our computer or not. Let us see Maven is working in our computer or not. MVN-v is the command to check the Maven version. Java -version to check the Java version. Maven -v to check the Maven version. Everything is clearly given in the document. MVN-version or -v. Anything is fine. MVN-version to verify that Maven is installed successfully or not. Yes, you can see when I execute MVN-version, it is saying that Apache Maven 3.8.6 is running. That Maven is running based on this Java 1.8 version. So how to verify Java version and Maven version now? Java -version to check Java version, Java is installed or not. Next one, Maven MVN means Maven version. So in my computer, now Java is working as well as Maven is working. So with this, environment setup is completed. So as part of environment setup, what we have done, download and install Java software. The first step, download and install Java software from Oracle website. Set path for Java. Set path for Java. Add Java home. Set path for Java and add Java home. Then fourth one, download Maven software. Download Maven software. Fifth step, set path for Maven. Set path for Maven. Sixth step, add Maven home. Add Maven home. Verify Java version. Verify Java version and verify Maven version. Verify Java version and verify Maven version. So this is called our Maven setup, guys. Environment setup to work with Maven installation, or I can say this is my environment setup, Maven environment setup. So I want you people to perform these operations before coming to today's evening class. Today's evening class. So today evening, we are going to work with the Maven. To work with the Maven, first we need to set up the Maven. So how to set up the Maven that you have seen now. So here I have given the software setup clearly, Maven installation. Okay, so download and install the Java. When we install, you will get two things, JDK and JRE. JDK contains the tools, JRE is a platform. This is the URL to download. Set up the environment variables, Java home, right? Here, Java home, path up to JDK directory. Path for Java, go to system environment variables, env variables, system variables, select a path and click on edit, then add the JDK path like below up to bin directory. To bin directory. Step by step, I have given clearly, guys. Now, verify Java installation by using this command. Then download Apache Maven software from this URL. You can download any version. When I prepared this document, it was 3.8.5. So today it is 3.9.0. Okay, guys. So download Apache binary archive. Extract Maven zip file, then paste in the C drive. Then set the Maven home. This is my file name. Let me give the latest file name in the document. Yeah, this is the latest file. So then set the Maven home up to this 3.9.0 location, whatever the file you download. Then set the Maven home and set the Maven path 3.9.0. Okay, once it is done, then check the Maven version. I want you to complete this before coming to today's evening session. Today evening, we are going to understand Maven terminology, and we will be creating a project by using Maven, and we'll start working with the Maven. Are you guys clear? Are you guys clear with this? Perfect. Any questions, anyone? You can unmute your mic.
Ashok,
Yes, sir.
you're talking about on evening classes. How about for some of us that are not in India, like we're in the US, we can definitely attend that. It will be.
Yeah, that is only for today, sir. That is only for today, one day.
Okay, but would the video be available?
Yeah, video will be available. Yesterday also I have taken extra class. That video already uploaded. Today one extra class I'm going to take, and I will upload that video also.
Okay, because for us we are already in the evening here.
I agree, sir. I agree. The reason for taking the class is
I understand. You told me you're traveling.
Yeah, right.
Yeah. Okay.
So evening 9 p.m. class will be available today evening. Don't miss it, guys. So we are going to understand Maven terminology in the today's evening class.
Okay, thank you.
That video will be uploaded immediately after the class. Anybody who is working in a different country, due to time zone, they may not be able to attend. For them, video I'm giving immediately. Good. All of you should complete this Java and Maven setup before coming to today's evening class. Class notes will be uploaded to portal now. Yes, sir.
Sir, I have installed Maven already, and we should install again.
Not required. If Maven is already available, you don't need to install again. If you have not installed, then you need to.
Okay, sir. Thank you.
Ashok, one question from my side.
Ashok?
Yes, sir. Yep.
So the project development is also part of this course because what we are going to build it. So definitely we should have some project, right, to build it, right?
Yeah, I will give you that.
Okay.
Yeah, in my system I have Java 18. Hi, this
No
is
problem.
Yash. So
Yeah, no
like
problem.
my question is like I can download Java 1.8 in my system. So like I can use both versions.
You can use if you download both versions, for which version you will set the path, that version it is going to consider.
Okay.
Ashok?
Yep.
Can you upload this video in next 1 hour or so that if we have any doubts, if we get stuck somewhere, we'll check the video.
Sure.
And I have a couple of questions regarding yesterday's class.
Yeah, you can post in the group. I will answer that.
Okay.
Yeah. Thank you, guys. So I'm expecting everybody will complete the setup before coming to today's evening class. So in the today's evening class, we are going to discuss Maven terminology. That's very, very, very important. Don't miss that class, guys. In the Indian time zone, it is 9 p.m. IST.
Sir, we are not able to see the status class notes in the.
Sir, we are not getting the backup video, sir.
Yesterday I have uploaded the notes, right?
I'm not able to see, so that is what.
No. I have uploaded the notes. Guys, remaining people, yesterday final notes, are you able to see?
Yes, sir.
Yes, sir. Yes, sir.
Sir, I'm not getting my backup video soon.
Please talk to admin team. Please talk to admin team. Okay. Yesterday
Ashok,
video I have uploaded immediately after the class is completed. Please
Ashok, one
check
more
that.
question.
Yes, sir.
How much time it will take, like these tools, these 14 tools, including Docker and Kubernetes also?
2 months.
No. Particular these tools. After that, you will start AWS also, no?
Only these tools will take 2 months.
Okay, all right.
Yeah. Because the Docker and Kubernetes will take a lot of time.
Okay.
Guys, yesterday video already we have published. People are saying that it is not available. Please check that.
It is available. Yeah. For
Yeah.
yesterday's, both the videos got uploaded.
Correct. Fine, guys. Thank you. We'll meet in the evening class. For Indians, it is evening. For US people, your morning. Yeah. So it is 9 p.m. IST. Please check the time zone. Thank you, guys.